Hi again, hello, good morning, and welcome to the online class for Calculus 2. In today's lesson, we are going to talk about the definition of area as a limit, and of course, a very powerful technique in doing so, in finding the area of a curve, which is called the sigma notation. Okay, if you would recall, nung ating introductory lessons, so in integral calculus or calculus 2, na-discuss natin doon kung saan nanggaling ang integral calculus, which is, sabi nga natin, for what we know, nag-umpisa sa area problem, which is getting the area under a certain curve. And there, for many years, na-baffled yung mga mathematicians paano kunin ang area ng um, isang irregular shape curve, no? Unlike yung regular shapes na meron na tayong known formulas sa geometry. Whereas kapag hindi na siya regular or regular na shape na siya, wala tayong um, specific formula in finding the area of that certain curve. And from there, na-discuss natin yung iba't ibang methods. So, ang first attempt is yung method of exhaustion, wherein they try to approximate. For example, if in-apply natin yun sa area ng circle, what they do is under method of exhaustion, you try to fit a polygon with as many sides as you can, which will eventually approximate the area of the circle. And then we also discuss the rectangular method, wherein if you have an irregularly shaped curve, um, inahati natin siya into rectangular strips, uniform rectangular strips, or rectangular strips with uniform width, and we make the number of rectangles as many as we can para ma-approximate yung area under the curve. Okay. And then we are introduced to indefinite integral. However, hindi tayo nagkaroon ng in-depth discussion regarding the rectangular method. And also, hindi natin in-approach or nilimit as the number of rectangles approaches infinity. So, nag-set lang tayo ng certain number of n for the number of rectangles dun sa rectangle method. In this lesson, we will be going to have an in-depth discussion regarding the method of rectangle or rectangle method in getting the area of a function as a limit. So this time, we take the limit as n, or the number of sides or the number of rectangles in the curve approaches infinity. And to do so, we are going to discuss first a very useful technique which is called the sigma notation or the summation. Okay, I think you are already familiar with this from your early courses, but still, we will discuss it here. Okay, suppose we are given a sum, 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. And as you can see, yung ating mga terms can be expressed as a perfect square because 1 squared, 2 squared, 3 squared, 4 squared, 5 squared are square numbers. So, pwede nating express each term as a square. Yan. And since we are getting the sum, we use the sigma notation or the summation yung tinatawag natin. And from here, tingnan nyo, ang nagbabago lang naman dito sa term natin is they are all square numbers. Right? Ang exponent nila lahat is 2. At ang nagbabago lang is yung base niya from 1 to 5. So in sigma notation, we represent this as the summation of k squared from k equals 1 to 5. K, yung nagbabago, ang tawag natin doon, the letter K is called index, although it's not always K. you can change the index to any variable or letter that you want. But for this example, I used k, the lower limit 1, the upper limit 5. 1 is the lower limit, which means dito ka magsisimula. It is where the summation starts, or it is where the value of k starts. And the upper limit 5 is where the value of k ends. And the summation notation, or the sigma, Greek letter sigma, is, denotes that we are going to add every term, which is k squared, where k is from 1 to 5. So kapag binasa po natin ito, ang ibig sabihin nito is the summation of k squared from k equals 1 to 5, or the summation of k squared from k equals 1 to k equals 5, or 1 to 5. Yun. We can actually generalize k squared to any function. Sabihin na natin f of k, since yung function natin is a function of the index, right? Ang index natin is k. Ibig sabihin, nagbabago yung value ng function natin depende dun sa gagamitin natin or value ng k na index. And as what I've said a while ago, yung lower limit, doon tayo nagsisimula, and the upper limit is doon tayo nagtatapos. And the signal notation, of course, tells us to add everything. So let's have a few examples. So evaluate daw natin yung given summation. Okay, for number 1, we have the summation of k cubed from k equals 4 to k equals 8. So this only means na kukunin natin yung sum ng cubes ng numbers from 4 to 8. So this means pag in-expand natin yung summation, 4 cubed plus 5 cubed plus 6 cubed plus 7 cubed plus 8 cubed, and that is equal to, this is equal to 1,260. See? Basic lang. So, hindi lang naman laging naka-exponent lang or a power lang k squared at k cubed. Pwede rin po na product siya. Or any function, basta meron po tayong index na k. And again, hindi lang din laging k ang ginagamit. We can use other variables. So for this example, we were going to add, or the summation of 2k from k equals 1 to 5 means 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. Okay, remember na yung k lang yung babaguhin natin. So, wag natin baguhin yung any numbers, any power, any anything, constant man yan, or any other variable. Wag nating babaguhin. Ang babaguhin lang natin is yung given index. Okay, that's why may nakalagay na k equals 1 dito. Although yung iba, hindi na nilalagay yung k equals 1. Minsan 1 to 5 na lang yon. And if iisa lang po yung variable dito, that would of course obviously mean na yung k lang yung nagbabago. But in case na to be safe, nilalagay yung k equals 1 kasi if for example meron tayong ibang variable na nakalagay dyan, for example 2a k, so hindi mo papalitan sa a since yung index natin is k as indicated by our lower limit, k equals 1 to 5. So dapat si 2a hindi mo siya papalitan ng 1 to 5 din, baka isama nyo, no? Kung ano lang talaga yung index, yun lang po yung babaguhin. And for this, we get 2, 4, 6, 8, 10. Ilan kaya ito? 30, sir. 30. Okay. para hindi na ako mag-type. 30. Okay. Then, the third example, from 0 to 5 naman, summation of 2k plus 1. So, 2 times 0 plus 1 plus 2 times 1 plus 1 plus 2 times 2 plus 1 plus 2 times 3 plus 1 plus 2 times 4 plus 1 at 2 times 5 plus 1. That is equal to 36. That is equal to 36. Excuse lang. See? Actually, itong second and third examples, pwede natin yan i-simplify, pero mamaya ko i-discuss. Kasi as you can see, si 2, it is not affected by, by the value of k. So, meron tayong theorem, the linear property actually, the linearity of a, pwede nating ilabas yung 2. Total, hindi naman niya na-apektuhan yung k. Same is true in the third example. Hindi niya rin na-apektuhan si k. So, pwede rin ganito ang maging tsura ng ating example or yung function natin, kinukuha ng summation. So, summation of negative 1 raised to k times 2k plus 1. From k equals 0 to 5, so this means negative 1 to 0 times, ayan, medyo mahaba ata to 2 times 0 plus 1 plus negative 1 raised to 1, 2 times 1 plus 1 plus negative 1 squared times 2 times 2 plus 1 plus negative 1 cubed times 2 times 3 plus 1 plus negative 1 raised to 4, 2 times 4 plus 1 plus negative 1 raised to 5, 2 times 5 plus 1. And that is equal to equals negative 6. Fifth example, so from k sine of k pi over 5, k pi, from k equals 1 to 3. So we get, first, when k equals 1, syempre hindi na natin ilalagay yung 1. So we get sine of pi over 5 plus sine of, 2. So meron tayong 2 dito sa labas, 2 sine of 2 pi all over 5 plus 3 sine of 3 pi all over 5. Okay. So, one of the properties ng summation is we can change the limits, no? Hindi fix yung limits. We can change the limits as long as hindi natin binabago yung ibig sabihin or yung magiging expansion niya. Okay, as long as if in-expand ko siya, I still get the terms that I should have in the first summation prior to changing the limits. Okay lang. So for example here, I have 3 summations here and we can see na parehas lang yung ibig sabihin nito, although iba-iba sila ng limits. And you can see also na by changing the limits, nag-iiba din yung kinukuha na natin yung summation or yung expression, yung function natin. So, for example, for the first summation, we get, since that is summation of 2i from I equals 1 to 5, we get 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. For the second summation, nag-change tayo ng index or the limits pala, sorry. Also, nag-change din tayo ng index na j. Nag-change tayo ng limits from 0 to 4. So, as you can see, na-shift siya. So, we get 2 times 0 plus 2 plus 2 times 1 plus 2 plus 2 times 2 plus 2 plus 2 times 3 plus 2, 2 plus 2 times 4 plus 2. Okay? Pag sinimplify mo yan, meron kang 2 plus 1, 2 times 1, meron kang 2 times 2, plus 2 times 3, plus 2 times 4. Tapos bilangin mo yung naka-plus 2. 1, 2, 3, 4, 5. Meron ka pang 2 times 5. So, parehas lang siya dito sa una. This only means that we can change the limits, lower and upper limits. And also, by doing so, nababago din yung ating equation or yung function. So, for number 3, we try to solve. We get 2 times 3 minus 4 plus 2 times 4 minus 4. Ang dami pala nito. Plus, dapat nilitan ko yung sulat ko. 2 times 5 minus 4 plus 2 times 6 minus 4 plus 2 times 7 minus 4. And you can see, meron kang 2 times 3 plus 2 times 4 plus 2 times 5. Tama? Plus 2 times 6 plus 2 times 7. Then, meron kang ilang minus 4 yun? 1, 2, 3, 4, 5. So, that is minus 4 times 5 or equal lang yan sa minus 2. Yung minus 4 times 5, pwede nating i-write as minus 2 times 10. And then yung plus 2 plus 2 times 6, 2 times 7 minus 2 times 10. That is actually 2 times 3. Hindi ko siya sinisimplify, no? Para lang makita nyo na parehas lang yung expansion. Although, ang pinakamabilis is isimplify mo yan and you get the same result. Okay. So, itong 2 times 6, 2 times 7, 2 times 10. This is 2 times 13, tapos minus 2 times 10. So, you get 2 times 3. And 2 times 3 is equal to 2 times 2 plus 2 times 1. Kaya, nakompleto mo ulit yung from 2 times 1 to 2 times 5 na yun yung original or yung una nating summation. But the main point here is you can change the limits of summation. You can adjust the limits of summation according to what is needed in the problem. Kasi kailangan natin mag-change ng limits para mas mapadali or mas masimplify or para mas maging evident yung sinosolve natin. Later on, siguro, I think meron ako isang example doon na nag-change ng limit. And then, other properties of sums, aside from we can change the limit, is here. Okay, suppose that our function, usually, yung function na f of k kanina dun sa generalization natin, okay, dahil a function naman siya ng k, okay, usually nire-write na lang siya as a sub k, where a is the function is k is the index. So that means, ang ibig sabihin ng a sub k from k equals 1 to n is a1, a sub 1 plus a sub 2 plus a sub 3 hanggang a sub n, where yung an, ibig sabihin lang nun is f of 1. Okay? Or kapag 1 yung value ng k. Wala naman masyadong pinagkaiba sa meaning. Ginawa lang ganong notation para mas magandang tignan. Mas convenient din. Kesa yung maglagay ka ng f of 1, ganyan-ganyan. Mas convenient yung may subscript. So, here the properties of sum. Kapag meron kang, okay, kapag yung function mo or yung a of k mo is minultiply ng certain constant or hindi lang siya constant, anything, or it can be also a function, basta't hindi siya nakadepende kay k, it is not affected by the changes of k from lower limit to upper limit, pwede mo siyang i-factor out. Ibig sabihin, ilabas mo siya outside the summation, and then yung magiging sagot mo dito will be all multiplied by that c na nilabas natin kasi hindi siya affected. Bukod doon, second property is, if you can write your function as a sum of two other functions, which is also, of course, dependent on k, pwede natin siyang paghiwalayin. Okay, I'll just give you a quick proof. For letter A, for example, yung ano natin, yung, sige, ito na lang, CAK, from k equals 1 to n, di ba? So, pag in-expand kasi natin yan, we get CA1 plus CA2 plus CA3 plus CA4 and so on up to CAN. And as you can see, si C, hindi naman siya nagbabago. So, pwede mo siyang i-factor out and then you get A1 plus A2 plus A3 plus A4 up to, of course, AN. And this means that we can get the summation of AK from K equals 1 to N. So, yan yung proof for letter A. Kaya, pwede mong ilabas si C since it is not affected by K. The proof of letter B, burahin ko muna. Okay. Ito, expand mo itong nandito. Dapat pareha siya dito para ma-prove natin. So, summation ng AK plus BK from K equals 1 to N means, if in-expand natin, A1 plus B1 plus A2 plus B2 plus and so on hanggang AN plus BN. As you can see, pwede mo siyang i-rearrange na kung saan magkakasama lahat ng A and then magkakasama lahat ng B. So, madaling sabi, diba, this will simplify to the summation of AK from K equals 1 to N, and this for B, mag-simplify siya as the summation of BK from K equals 1 to N. And so, na-prove mo na equal lang siya. And ganun lang din kapag for the subtraction, no, AK minus BK. So, magma-minus lang si BK dito, o yung mga B, sa expansion niya magma-minus, and then you can factor out the negative sign or the minus sign, and then what is left on the, sa dulo is summation lang din ng BK. So, same lang po yung proof for B and C. So, these are the properties. So, mas mapapadali yung pag-expand natin or pag-simplify natin ng mga summation kapag alam natin itong mga properties nito. Yan. So, yan. Na-establish na natin yung summation notation and some of its properties and solve na ng example. Let's go dun sa paano siya ina-apply sa definition ng area using the rectangle method. Kasi last time, na-discuss natin to na mayroong rectangle method and paano nagkaroon ng indefinite integral gamit yan. Pero hindi tayo actually nagkaroon ng mas malalim na discussion. So, let's go back to the concept of finding the area under the curve. For example, meron tayong area bounded by a function y equals f of x, and then sa baba, bounded by the x-axis, and from left to right, bounded siya ng x equals a, or a, and x equals b. From the discuss natin na rectangle method, ang gagawin natin is i-divide natin yan, tama, into rectangle strips. Yan. Ang property ng mga rectangle strips na yan, or rectangle, is una, pipili tayo ng intervals between AB such that equal yung intervals. Ibig sabihin, yung from point A to x1 is equal ang distance. So, tawagin na natin siyang delta x. From x1 to x2, equal lang din. So, delta x lang. So, hanggang x minus 1. So meron tayong n numbers ng delta x or n strips. And then from this subinterval or intervals between AB, mapapansin natin na ang length or ang ating length ng delta x, length nung interval or yung width nung ating rectangle is equal to b minus a divided by n. Kasi from A to B siya, tama? A to B is the total distance or yung boundary, isang boundary nung nung curve. And since dinivide natin siya into n numbers, dinivide natin siya into rectangles na ang bilang ay n and equal siya, therefore bawat hati na delta x ay merong width na b minus a divided by n. Okay? Kasi equal nga. So, i-divide mo lang siya kung ilan i-divide mo lang yung total length, total ng interval from A to B by the number of n or by the number of strips, which is n. Number of rectangles na hatian mo. So, pakitake note itong formula na to. Ito yung width ng bawat rectangle. And then, of course, para kompleto yung rectangle, dapat meron siyang length, hindi lang siya width. Okay. Yung length or yung height ng rectangle, kasi vertical siya, pipili tayo ng subinterval between each interval. So, for example, from A to x1, pipili ako ng point sa loob nun na kung saan yung height is equal to the function itself. So, it doesn't matter kung anong point, no? Pwedeng nandito, pwedeng nandun, pwedeng nandun. As long as yung point na yon is equal dun sa function or nandun mismo dun sa curve na nasa taas. Okay, it doesn't matter kung nasaan siya. Nasa gitna man, nasa left, nasa right, in between the interval of A to x1. So, ang mahalaga is it intersects the curve or yung upper boundary natin na y equals f of x. The point is in the y of f(x). Y equals f of x. And gagawin mo yan sa lahat ng rectangles. So, pipili ka dun sa AX1, then between x1 and x2, pipili ka ulit ng point between them, okay, na magsisilbing length ng rectangle natin. And from there, I-zoom natin. So, tingin tayo ng isang rectangle. Ang area ng rectangle is length times width, tama? Is length times width. Yung width natin, alam na natin kanina, that is delta x. And then, yung height natin, pinili natin since it intersects the curve na nasa taas. Ibig sabihin, this point, yung height na to is actually the value of the curve or yung upper boundary, which is y equals f of x. But since pinili natin yung point sa baba, so that is f of k, okay, the value of the curve evaluated at the chosen point in this subinterval, yun yung magiging length, yung value ng curve. Therefore, ang area natin is ito lang. Yan, length times width lang yan actually. As you can see in the diagram. Yung width, ito yung b minus a divided by n kanina. Yung uniform width ng rectangles. Yung length, nakadepende sa height ng rectangles. Nakadepende sa value ng function. Kung saan mo pinili yung point within the subinterval. And kapag kinuha mo na yung total area under the curve, syempre, isasum mo lahat ng rectangles na yan, no? So, rectangle 1 times plus rectangle 2 plus rectangle 3 plus rectangle 3 hanggang kung ilang mga rectangles yan. So, gagamitin mo lang yung summation na formula. So, the area of the shaded region R, or the under the curve ng y equals f of x, is approximately the area of Rn, where Rn is the sum ng area ng individual rectangles. And kaya nga natin pinag-aralan yung sigma notation or summation notation kanina is para magamit dito. So, the area can now be approximated as, of course, f of x as star k times delta x from k equals 1 to n. So, I'd just like to point out na yung delta x, which is the width, is not affected by k here. Kasi di ba uniform yung width natin. So, kahit ilang mga rectangles yan, bawat rectangle, uniform, pare-pare sila ng delta k. So, hindi siya affected ng k. Yung k is yun yung bilang nung rectangles. Okay? And as you can see, dun sa graph natin kanina, magkakaiba yung value nung height. Therefore, yung height lang or yung length, yun lang ang nagdedepende dun sa value ng k, which is from 1 to n. And, sabi ko nga last time, dun sa first lesson, as habang pinaparamihan natin or dinadamihan natin yung value ng n, which is the value ng or bilang ng rectangles, mas lumalapit tayo dun sa true area R. So, mas nagiging accurate, mas marami, mas maganda. Kaya, if we set the limit, kapag ginawa nating n approaches infinity, ayun na siya. Hindi na lang siya basta approximate. Nagiging, yun na mismo yung value or exact area under the curve. Under the function y of x bounded between the interval from a to b. So, ito po yung area, definition ng area using limits and of course the rectangle method. Any questions? Okay, so formally, ang definition ng area under the curve is ito. If a function f is continuous on interval ab, and if f of x is greater than or equal to 0 for all x in ab, then the area under the curve y f of x over the interval ab is defined by area equals the limit of summation ng f of x star k delta x from k equals 1 to n as n approaches positive infinity. Yan yung definition natin ng area under a curve. So, So, i-apply natin yung definition na yan. Ayan. Okay. Marahil sabihin nyo kasi, pwede nyo sabihin kasi kanina, yung curve natin, yung rectangle, di ba? Sabi ko, arbitrary or kahit anong point yung kunin mo between the subinterval as long as nandun siya or as long as it is equal to the value of y equals f of x, yung length magiging y equals f of x, or na-intersect niya yung upper boundary, yung curve na y equals f of x, okay lang. Kahit saan dun sa loob ng point na yan. So, pwede yung sabihin, sir, hindi ba pwede, baka magbago-bago kasi hindi naman fixed pala. So, yung point parang iba-iba. So, hindi ba naiiba din yung sagot ng area? Actually, hindi. Na-prove na rin yan sa higher courses or higher, yung mga subjects higher than integral calculus. Pwede yung i-prove pero hindi na scope natin. Pero it is proven na kahit anong point ang piliin mo inside this subinterval, as long as y, yung value niya is y equals f of x, okay lang. It doesn't matter what point it is. Pero may mga convention na ginagamit ng pagpili kung anong point. So, meron tayong tinatawag na left end point, may right end point, and midpoint. And meron silang kanya-kanyang values ng x star k or yung value ng point within the subinterval. Kapag ginamit yung left end point, ang value ng x star k is ito, a plus k minus delta x. Paki-take note. Kapag right end point, a plus k delta x. Then kapag midpoint, a plus k minus 1/2 delta x. So, depende. Pero sabi ko nga, it doesn't matter kahit kahit anong convention, left end point, right end point, midpoint, or kahit anong point within the subinterval, makukuha mo same lang na area. Okay, let's try to solve examples. Ayan. Yung pagpili ng x star 1, x star 2. Ito yung convention, although sabi ko nga, yung doesn't matter what point within the subinterval. Okay, wala. Pag rinaf po natin yung f of x equals x squared, ganito yan. Parabola yan, di ba? Pangit naman ang parabola ko. Ganyan. Ito yung 1. Ito yung origin, syempre, 0. So, ito yung pinapakuha nating curve. Ito yung pinapakuha nating area under the curve. Ang gagamitin natin is, of course, the definition of area under the curve. Ano po yung formula natin? Area is equal to the limit of summation ng fx star k delta x from k equals 1 to infinity to n, as n approaches positive infinity. Okay. Ang x of k natin, x star k natin, since it uses the right endpoint, is equal to a plus k delta x. Okay. Remember, yung interval natin is 0, 1. So, this means ang a natin is 0 and ang b natin is 1. And yung area, yung function na given natin is x squared. Therefore, pwede nating palitan yung ating f of x star k dyan ng alin? X squared or x star k squared delta x. Okay, bakit nyo pinalitan ng x star k squared? Sir, kasi yun yung given function. Di ba? Kahit anong point dyan between a and b, ang value ng f of x natin is x squared. So, pinalitan ko lang yun ng x squared. And then, di ba ang value ng x star k natin is a plus k delta x? Kaya, pwede natin din yung palitan ulit. Positive infinity, walang positive to. Summation ng k equals 1 to n. So, magiging a plus k delta x squared yan. Okay, kasi yung x star k equal yan dyan sa a plus k delta x. Saan galing ito? Kasi right endpoint yung ginamit or pinapagamit sa atin na convention. And then, multiply to delta x. Approaches positive infinity equals summation ng i-simplify lang natin ito. Expand natin yung a plus k delta x. We got a squared plus 2ak delta x plus k delta x, k squared delta x squared. Then, i-multiply mo pa ulit. Okay, wala na naman akong space. This is the limit as n approaches positive infinity ng, dapat wala palang equal dito. Kaya pala ako nasasayangan. K equals 1 to n a squared delta x. Dinidistribute ko na ngayon yung delta x, okay? Plus 2ak delta x squared plus k squared delta x cube na siya. Kasi squared siya dito, then meron siyang cube. Okay. Remember, ang value natin ng a natin is what? 0. B natin ay 1. So, lahat ng may squared dito, magzi-0 na yan. Wala na yan. So, ang matitira na lang dito actually is the limit as n approaches positive infinity, summation ng k equals 1 to n, k squared. Ano ang value ng delta k squared? Ng delta k? Delta x. Yung formula natin ng delta x ay b minus a divided by n. Tama? Pero ang b natin is 1, ang a natin is 0, so that is n. Therefore, ang delta x natin is 1 all over n. Dapat pala kinumpute ko na to kanina. So that is 1 all over, yung delta x natin dito, magiging 1 all over n cube. Lipat na ako sa taas, ha? Okay. Dito sa taas, kopyahin ko itong last equation. Ito. So, area is equal to the limit of summation ng, okay, simplify ko na si 1 all over n cube dito, magiging 1 all over n cube. And as you can see, hindi siya affected ng k kasi si n dyan is a constant. Hindi siya affected ng k. So, actually, pwede mo na siyang ilabas. So, mangyayari is, nandito na siya sa 1 all over n cube, limit of okay. Hindi ko muna siya ilalabas pala. Sorry. Hindi ko muna siya ilalabas. Nandito lang siya. Limit ng as n approaches positive infinity, dito lang siya, sa labas ng summation. Familiar ba itong summation ng k squared from k equals 1 to n? Yes po. Formula po yan na kanina. That is equal to, ang formula ng k squared ay, summation ng k squared from k equals 1 to n is n times n plus 1 times 2n plus 1 divided by 6. Wala na talaga akong space. And that is equal to n times n plus 1 times 2n plus 1 divided by 6n cubed. Okay? I-rearrange ko lang siya. The limit as n approaches positive infinity. So, ilalabas ko yung 1/6 times, di meron na lang n cube sa baba. Tama? Yung n cube na yun, pagkahatian ko na, pwede kong gawin as n times n times n. So, ang mangyayari, n all over n times n plus 1 all over n times 2n plus 1 all over n. Tama ba? Parehas ba yan sa n times n plus 1 times 2n plus 1 all over 6n cube? Yes, kasi nakamultiply naman yung denominator and numerator. Pinaghiwa-hiwalay ko lang sila. Limit as n approaches positive infinity. 1/6. N all over n, that is 1. N plus 1 all over n can be written as 1 plus 1 all over n. Then, times 2n plus 1 all over n can be written as 2 plus 1 all over n. Pwede na tayong mag-limit. As n approaches infinity, ito, 1 all over infinity yon. Tama? And 1 all over infinity is what? As the denominator ng 1 all over n grows larger, habang palaki ng palaki sa n, naka-fraction yan. Paliit ng paliit yung value natin. So, as n approaches infinity, 1 all over n approaches 0. 1 all over n approaches 0. That way, ang matitira na lang is 1 all over 6 times 1 times 1 times 2. Therefore, ang area natin is 1 all over 6 times 1 times 1 times 2. That is 1/3 or 2 over 6. Final area under the curve is 2 all over 6 or 1/3. Charan. Okay. So, next example. So, let's try. Baka mas medyo less madugo. Wala pala. Dadagdagan lang natin yung use for formulas natin as a consequence ng unang example. Para just in case, makita natin itong mga, sabihin natin template na to, hindi na tayo mag-evaluate ng limit ng paulit-ulit. So, which is for, kagaya nga na ito actually yung definition ng, or yung example number 1 natin. So, equal yan sa 1/3. And kapag na-encounter natin itong mga limits ng summations ng mga ito is, i-memorize na lang siya para from time to time, pag nakita natin at nag-evaluate tayo, or kinuha natin ng area under the curve, hindi na tayo mag-evaluate ulit ng limits. Automatic, 1 na yan. 1/3, 1/2, 1/4 agad yung sagot natin. So, madali lang naman siyang i-memorize. So, kung 1 yung nasa loob, at 1n din yung nasa labas, si exponent ng n is 1. 1 naman ang sagot, nung limit ng summation. Kung k squared, tapos n cube yung nasa labas, 1/3 yung sagot. Pag k, tapos n squared yung nasa labas, 1/n squared yung nasa labas, 1/2 yung sagot. So, basically, ang susundin mo is kung ano man yung exponent na n dun sa labas. Or, kung gusto mong sundin naman si k, dadagdagan mo lang ng 1. So, k squared to, so ang sagot 1/3. Kasi 1/2 plus 1. K ito, so 1 plus 1 is 2, kaya 1/2. K raised to 3 ito, 3 plus 1 is 4, kaya 1/4. So, pag nakita natin or na-encounter natin itong mga limits na to, pag kumukuha tayo ng area under the curve, hindi na natin kailangang i-solve. Although you can, if you want, you can prove it on your own. Ayan. So, let's see another example. Using the definition of area under the curve, again, that is area equals the limit of summation ng f of x star k delta x from k equals 1 to n as n approaches positive infinity. Take note, delta x is equal to b minus a all over n. And ang x star k is depende din sa gagamitin niyang convention. Ang gamit natin is midpoint. Therefore, x star k should be a plus k minus 1/2 delta x. So actually dito pa lang pwede mo nang i-calculate si x star k for all values ng f of x. Kasi ang delta x naman natin is b minus a all over n. So a plus k minus 1/2 times b minus a divided by n. Ang a natin ay 0, tama? Kasi yun yung interval natin from a to b. So 0 to 3, a is 0, b equals 3. So a magiging 0 yan, ito magiging 0 din. So makukuha mo is k minus 1/2 times 3 all over n. Okay. Inisip ko kung i-substitute or i-simplify. Pero ganyan na lang muna. So, yan na yung magiging xk natin. Now, we get the area na. The limit ng summation ng k equals 1 to n. F of x star k nakadepende sa function which is 9 minus x squared. So, magiging 9 minus x star k squared times delta x. So, yung delta x natin dito is 3 minus 0 all over n, which is 3 all over n. Yung x star k natin is k minus 1/2 times 3n. So, ang kalalabasan po niyan is limit as n approaches positive infinity, summation of 9 minus k minus 1/2 times 3n, then lahat yan naka-squared, tapos meron ka pang delta x sa labas which is also equal to 3 all over n. So, si x star k, kinuha lang natin po dito sa ating formula which is galing sa midpoint. Okay, dahil midpoint, kaya ganyan yung naging formula. Okay, simplify n as limit of summation ng 9 minus Ano ito? Okay. Yung medyo may mali tayo dito ng konti, pero hindi naman mali. Kulang lang ng parenthesis. Si delta x kasi, nakamultiply yan kay 9 and minus x star k squared. So, lalagyan mo pa dapat ng another brace or parenthesis dyan. That means na dapat may nakamultiply na 3 all over n kay 9. So, pag dinistribute natin dyan, makukuha natin is 27 all over n. And then, pag dinistribute din natin siya dito sa kabila, minus, yung k minus 1 half and 3 all over n ay may both naka-raise sa 2. So, k minus 1 half squared. Then, of course, meron ding si 3 all over n squared. Pero, imumultiply mo siya ulit ng 3 all over n sa labas. So, magkakaroon ka na ng 3 all over n cube. That is equal to limit ng n approaches infinity, summation of 27 all over n minus k minus 1 half squared 27 all over n cube. Lahat yan naka-summation. Dito na ako ulit sa taas. Wala na naman akong space. Next natin gagawin is i-expand yung k minus 1 half squared dito sa baba. Expand lang natin. So, area equals again the limit as n approaches positive infinity ng k equals 1 to n, 27 all over n, walang gagawin sa kanya, minus, ilagay ko na sa unahan si 27 all over n cube, times, expand na natin si k minus 1 half squared, that is, k squared minus k plus 1/4. Tama. That is equal to, next na gagawin natin is, i-distribute si 27 all over n. So, 27 minus n, 27 all over n pa rin yan, minus 27 all over n cubed k squared, minus 27 all over n cubed k plus 27 all over 4n cubed. At wala na tayong paglalagyan. Kopyahin ko bago ako pumunta sa next na slide. Kasi I know mawawala na to. (27 all over n minus 27 over n cubed k squared minus 27 over n cubed k plus 27 over 4n cubed. Ayan. So, yung last equation natin is area equals the limit as n approaches positive infinity ng summation of k equals 1 to n, 27 all over n minus 27 all over n cubed k squared minus 27 all over n cubed k plus, kalaking plus naman, 27 all over 4n cubed. Summation yan, actually dapat meron yung parenthesis, pero carry lang. Ibig sabihin natin is, pwede natin i-distribute yung summation, but still lahat yan is nakalimit as n approaches positive infinity. So, tig-isa na ngayon sila ng summation. Minus. summation 27 all over n cubed k squared minus summation ng k equals 1 to n 27 all over n cubed k plus summation ng 27 all over 4n cubed. Still, it is the limit. Bakit ko nilalagyan ng division line? N approaches positive infinity. Okay. Dito, dapat pala nilabas ko na yung 27, no? Kasi para silang may 27. Pero okay lang yan. So, 27, pwede natin siyang ilabas ng 1 all over n. Okay? Actually, pati si 1 all over n, pwede mo siyang ilabas. 1 all over n approaches times 1. 1 na lang natira sa labas. Nilabas ko na si 27 all over n. So, k equals 1 to n. Bakit ko ginawa yun? Kasi 'di ba, formula natin to kanina. Yung latest formula na binigay ko, this will eventually be equal to, hindi. Kasama tong n, this will eventually be equal to 1. Yan. So, same lang din dito sa kabila naman. Labas natin si 27. So, fina-factor out ko lang siya para mas maging obvious na maging kamukha siya ng formula. Summation ng k squared from k equals 1 to n minus I think dapat may n squared lang to eh. So, meron ata tayong naging mali dun sa solution. Pero okay, let's just stick to that. 27 all over n cubed. 27 times 1 all over n cubed. Summation ng k from k equals 1 to n. Plus, so 27 all over 4, 1 all over n cubed, summation ng 1 from k equals 1 to n. Okay? Limit ng n approaches positive infinity. Ito na. I-apply natin yung apat na formula na sinabi ko. Ito ay magiging equal yan sa 1. So, 27 yan. Minus. Ito ay magiging equal sa 3. So, 27 times 3. Actually, 1/3 pala. Sorry, 1/3. Diba? Ito yung actually yung formula natin kanina. Yung example natin na nauna. Then minus, so ito, wala tayong formula. Kasi yung sa formula natin is naka-n squared. Kung k to, dapat n squared siya. So, pwede naman nating i-factor out to. So, instead of 1 all over n cubed, gawin nating 1 all over n times 1 all over n squared. Okay lang naman yon. And so, we are left with 27 times 1 all over n times, ito ay magiging 1/2. Okay? Plus 27 all over 4 times, ito din, pwede rin natin gawin tong factor out natin. Kasi dun sa formula natin, kailangan 1 all over n lang siya. So, yung 1 all over n cubed, pwede natin express as 1 all over n squared times 1 all over n para itong 1 all over n summation ng 1 from k equals 1 to n ay magiging 1. So, matitira, 27 all over 4 times 1 all over n squared times 1. Or wag na lang natin ilagay yung 1. So, that is equal to limit as n approaches positive infinity ng 27 minus 27 all over 3 is 9 minus 27 all over 2 times 1 all over n plus 27 all over 4 times 1 all over n squared. Okay, don't forget, meron pa tayong n or limit as n approaches infinity. So 27, wala naman siyang n, so hindi siya affected ng limit. Si minus 9, hindi rin siya affected ng limit. So, si 27 over 2 times 1 all over n, siya yung affected ng limit kasi nakamultiply siya ng 1 all over n. And again, as n approaches infinity, si 1 all over n will approach 0. Same is true for 27 all over 4 times 1 all over n squared. As n approaches infinity, 1 all over n squared will approach 0. So, 0 times 27 all over 4 is 0. 0 times 27 all over 2 is 0. So, matitira na lang po dyan is 27 minus 9, which is equal to 18. And that is the final answer. So, ayan. Dun sa example natin, dun sa definition ng area under a curve, we can see na yung curve natin, the curve is always positive between the interval AB. Ibig sabihin, it does not cross the x-axis. That is, meron siyang positive value lagi. Yung f of x is always positive. Okay, it does not change sign between the time interval or between the interval AB. But it is not always the case kasi hindi naman laging ganyan yung magiging graph. For example, we have a sine function, no, where it crosses the x-axis. Ibig sabihin, nagkakaroon tayo ng positive value ng y, then negative value ng y. So, ibig sabihin, magkakaroon din tayo ng positive value ng area, negative value ng area. And if we try to apply yung area under a curve, yung same process na ginawa natin sa mga examples, we can see na, yun nga, lahat ng area bounded by a positive y curve ay magkakaroon ng positive area. Yung negative naman, or negative, yung curve niya, negative yung y, magkakaroon din ng negative area. Kasi, di ba, dito, length niya is yung value ng y, which is f of x. And of course, delta x, yung width niya, positive. Nasa taas si y, so positive yung area. Dito, negative siya kasi yung value ng length niya is negative y or negative f of x. At kapag nagkaroon tayo ng function na ganito ang graph and kinuha na natin ang area between two intervals na kung saan yung area is nagkaroon ng crossing sa x-axis, ibig sabihin nagkaroon siya ng positive y and negative y functions or values. Kapag sinolve mo yung area nun, is hindi mo at in-apply mo yung kanina na method natin, which is the definition of yung may limit from n approaches as n approaches infinity, you can see na hindi mo actually kinukuha yung area, total area ng tatlong curves na to, kundi kinukuha mo yung net signed area. Ibig sabihin, kinukonsider mo yung symbol or sign ng area kung positive man o negative. Okay? Iba kasi yung pag sinabi mo lang na find the area, ibig sabihin, kunin mo yung absolute value nito, plus ito, plus ito, and you get a positive. Pero kapag in-apply mo yung definition natin kanina, ang nakukuha nun is net signed area. That is, ikinukonsider niya po yung negative areas and positive areas, and sinasum niya yun. Ibig sabihin, kunin mo muna lahat ng positive, and then ima-minus niya yung area lahat ng nasa baba. Kaya siya tinawag na net signed area. So, it is better lang na palitan natin yung definition natin. So, imbis na area under the curve, para ma-apply siya sa lahat ng functions, kasama na yung function na nagko-cross sa x-axis or nagkakaroon ng negative area, i-define na lang natin siya as net signed area instead of an area under the curve. Okay. Basically, parehas lang yung formula. So, dinefine lang natin siya para ma-generalize na hindi lang puro positive value na f of x ang kinukuha kasi hindi naman talaga ganun lahat ng functions. Okay, may mga functions na kailangan mag-cross sa x-axis. So, it is better to define it as a net signed area instead of area under the curve. Pero basically, parehas lang naman yung ibig sabihin niya. Okay. I will give you an example. Ito. Use the definition of a net signed area. Okay, pinalitan na natin, di ba? Kanina area under the curve, ngayon net signed area na. Kasi kung consider mo na yung positive and negative area. Left endpoint naman siya, sub-interval to confirm that the net signed area between the graph is, okay, you can calculate it gamit yung definition natin, okay, but I will leave it to you as an exercise. Pero kapag rinaf mo yung f of x, halata naman na magzi-zero kasi ganyan yung itsura ng graph ng x minus 1. And ang interval natin is from 0 to 1. So as you can see, nag-cross siya sa x-axis at point x equals 1 dito. And equal yung intervals na 0 to 1 and 1 to 2, equal yung length na yan, which is 1. And equal din yung value ng y, which is also 1. And as you can see, symmetric or congruent yung triangles na yan. Yun nga lang, yung area 2 ay magiging negative kasi nasa baba siya at ang kanyang y value is negative 1. Dito sa area 2 or area 1, positive yung area niya kasi ang y niya is positive. And kapag kinuha mo, in-apply mo yung limits ng summation as n approaches infinity, makukuha mo dapat 0 dapat yun. So, yun lang. Yun ang proper definition ng net signed area. Kapag ginagamit natin actually yung summation or limit as n approaches infinity ng summation ng blah blah blah, we are getting the net signed area, not just area under the curve. So, area under the curve siya kung positive lang lahat yung kinukuhanan natin ng area. Eh kung meron siyang negative, nagiging net signed area siya.